We're not dealing with any imaginary solutions in this, so we're only looking for real numbers on these. So I want to solve the cube root of 2x minus 4 with a minus 2 on the outside equals 0. Our strategy when we do these problems, our first step will be to isolate the radical. We want the radical on a side by itself. So if I want to get that radical by itself, what do we need to do? Add the 2 over. Then we need to undo the radical. We want it to go away. This is a cube root. Okay, if it were a square root, how would you get rid of a square root? What would you add to each side? If I said like the square root of x equals 4, how would you cancel a square root?
Put it on the left. Put the square root on each side.
You do that if you're canceling a square, right? So if I had said like x squared equals something, to get rid of the square, you would add a square root. So if I have a square root, to get rid of it, you would add a square. So if I have a cube root, to get rid of it, we add a cube to each side. So on the left, a cube root and a cube would just cancel each other out, and that radical disappears. So we have 2x minus 4 equals, what is 2 to the third? 8. So now we can solve this. Add over the 4. Divide by 2, and x is 6. We do need to make sure to check our answers on these. There will be times when you start adding squares and things in your problems, you can actually get an answer that does not work in the original problem. So when I say check, you are just plugging it back into the very original problem and making sure it works. You can do that on your calculator. I'm not looking for anything fancy. You don't have to show me any work for it, but you have to check it. So if we plugged in a 6, we would get 12 minus 4 is 8. The cube root of 8 is 2, and 2 minus 2 equals 0, so it does work. Or you could just plug it in your calculator. But you need to check because sometimes these numbers will not work at the end. Any questions on that one? You guys solve this one for me by itself. So we just get to cancel the radical. So the opposite of a cube root is a cube. You get 2t minus 1. 1 to the third power is 1. How do we move this over? So you get 2t equals 2. Divide by 2, so t is 1. Always check it at the end. Again, you don't necessarily have to show me that work. Now you get square root of 1, which is 1, so it does work out. So 1 is our answer. So far, so good? Let's go with this problem. So step 1 is isolate the radical, which we don't have to do anything for. It's already by itself. Then what do we have to do? Add a square. Now when you do that, you're squaring each side of this equation. So on the left, the square root and the square cancel and we just get x minus 1. But what am I going to have to do to square the bracket? We have to FOIL. So we get x minus 1 equals x squared minus 7x and minus 7x, so minus 14x plus 49. So this is a quadratic. What do we have to do?
Add like terms.
Add like terms. So we want to set it equal to 0, so I'll subtract over my x and add my 1. So we get 0 equals x squared minus 15x plus 50. So then we can do box method. X squared breaks into x. What multiplies to positive 50 and adds to negative 15.
Negative 5, negative 10.
Okay, so if we set each of those equal to 0, we get positive 5 and positive 10. Am I done?
No.
We have to check it. So if I put a 5 into the original, I get the square root of 5 minus 1 equals 5 minus 7. This is the square root of 4, which is 2. 5 minus 7 is negative 2. Does 2 equal negative 2? No, so 5 does not work. If we put in a 10, we get the square root of 9, which is 3, and 10 minus 7 is 3. So 10 does work. So my only answer here is positive 10. It is possible if you get two answers like this that one of them works and one doesn't. They could both work, or neither one could work. There's no guarantee. So you always have to check everything. Is that okay with everybody? Look at this. Alright, this has a lot of radicals in it, but it's really just going to be the same strategy. We just need to be careful about how we set things up. If I want to get rid of this radical, what do we have to do? Square. Okay. When I square, it will cancel the outside radical. So on this side, it cancels this one, my square. So then we still have 2 times the square root of 7x plus 2. So it only cancels one of the square roots at a time. On the other side, we only had a single square root, so squaring cancels it. We get 3x plus 2. Have I lost anybody there? We have two options for how to proceed. So I told you to isolate your radicals. If you try to get this radical by itself, what do you have to do with the 2? Divide it, and that will give us a fraction. That's okay, we can do it. If you don't like the idea of a fraction, we can keep the 2 here and work through it. So do you want to keep it or get a fraction?
Keep it. Keep it.
Keep it? Okay. I can go back and show you the other way too. So if we're going to keep that, and we square each side, you actually have 2 different things in here. You have a 2 and a square root, and we have to square both of those. So a 2 squared would be 4. When you square this square root, what happens to that?
Goes away.
The square root goes away. So as long as, if you don't divide over that 2, you just have to make sure you square it. All right? Then on the right, what are we going to have to do? FOIL that. (28x plus 8 over here. And then FOIL, we get 9x squared plus 6x and plus 6x is a 12x plus 4. So I'm going to set this equal to 0. So I'll subtract over that 28x and the 8. (12x minus 28x) 16x, positive 4 minus 8 is negative 4. What now? So these multiply to negative 36 and add to negative 16. I'll wait. A lot of you are just sitting here waiting for me to write the answer up here. I can't only leave 1 or 2 people trying to figure it out.
I did a great deal too.
Mm-hmm. So there's factors into 9x, 2, x minus 2. So then we set each of those equal to 0. And we get a negative 2/9 and positive 2. Are we done? Okay, so this one, it might be easiest just to do the calculator. I would like for everybody to try so you know how to plug these things in. So on the left, you have to go with the original. So we had the square root of 2 times the square root of 7 times negative 2/9 plus 2. And I get a beautiful decimal, so I'm going to plug in the other side. Square root of 3 times negative 2/9 plus 2. And I get the same decimal. So does negative 2/9 work? Yes. What's the other answer we got? 2. So if I plug in a 2. You have to plug it into both of them. We again get the same decimal for both. So both answers work this time. Anybody have trouble with that? Split my radical. So I have to add the 3, subtract the x.
Okay, I did that.
I'm just going to write that as 3 minus 6. All right, are we ready to square?
Wait, the negative thing going under the,
Yeesh.
Hmm?
the negative thing going under the x.
Yeah, I brought it. It was not under the radical. Sorry, did you write the problem down differently? Okay, I square each side. When I say square it, that means you have the entire side twice. Okay, if it helps you, you can write this out. So when you take 2 times 2, or 2 squared, you get 4. The square root of x times the square root of x is just x. Over here we have to FOIL, so we get 9 minus 3x, and minus 3x is minus 6x plus x squared. So let's set this equal to 0. I'm going to write my x squared first. Subtract over the 4. So now what do? Box method. What two numbers multiply to positive 9, add to negative 10? So if you set those equal to 0, we get 9 and 1. Am I done?
Check.
We have to check.
Check each one.
Go back to the original when you put them in. So if you put in 9, we'll get 9. Does it work?
Does it have to equal
It has to equal 0.
Then no.
So 9 does not. If we put in a 1, you get 1 plus 2 minus 3 equals 0, and that does work.
Bam.
So x equals 1 is the final answer. Alright. Questions there? Okay. So let's do, sorry, I'm kind of skipping around a little bit. Let's do a slightly different problem then. So we have the problems with radicals, and we can just take everything to a power and get rid of the radical. Let's say I gave you this problem. Alright. We could write this with radicals. We know that a 2/3 power just means this cube root of y squared. We did that yesterday, right? Minus 5 times the cube root of y plus 6. But this isn't all that friendly because I still have multiple radicals in it, don't I? We can do another thing though. Does this look at all familiar? At all like anything else that we might have solved? Where we have something squared. That, yeah, it's like a box method problem. It's not exactly the same because we don't just have x squared, x, and a constant. But if you wrote it in the radicals, you see you have the cube root of y squared. We have a cube root of y. We have a constant. So we could do box method here. If you have the cube root of y squared, what would you put in the front of each of these? The cube root of y. Remember, if we have an x squared, each one gets an x. So if we have a cube root of y squared, each one gets the cube root of y. Now, what multiplies to positive 6 and adds to negative 5? So if we set each of these equal to 0, we have the cube root of y equals 3. How do you get rid of the cube root?
Cube.
Cube each side. So we get y equals 27. Here we have the cube root of y equals 2. So to get rid of the cube root, we cube. So we get y equals 8. Why don't you guys check those for me? You can grab your calculator, plug them into the original, make sure they work. 27 to the 2/3 minus 5 times 27 to the 1/3 plus. Okay, could we do this one like the box method that we were just doing on the last one? Yep, we can. What's the other way we could do it? Yeah, what does a negative do? Yeah, it puts it on the bottom, right? So we could either treat this like a box method problem, or if I wrote it like this, isn't this like the type question you had on your last test? Couldn't you just take everything times x squared? So we have two options to solve it. Both of them will work. What do you want to do? Box method from the beginning? Okay. So if you prefer this way, you're welcome to work it from here. You'll just start out multiplying everything by x squared and go from there. So I'll leave you to that if that's what you want to do. That's one option. If you wanted to just try box method with the original, because it's not a 1 for the first coefficient, we have to go ahead and set this up. So 15 times 6 would be 90, so I need two things that multiply to 90 and add to 19. What would that be? 9 and 10. Okay, so when we factor these, we get 3x to the negative 1 and 2, 5x to the negative 1 and 3. Okay, so if you set these equal to 0, that x to the negative 1 just puts it on the bottom. So it's like saying 3 over x equals 2, negative 2, sorry. So if you multiply it over your x and divide, you get a negative 3 over 2. Okay, I can go back and work the other way too. So this is 5 over x equals negative 3, multiply over the x, and you get negative 5/3. And then of course we know how to check them. Do you guys want me to show you the other way for anyone that wants that? Okay. So if you multiply by your x squareds here, you would get 15 plus 19 over x times x squared would be 19x plus 6x squared equals 0. So then you do your box method. So these multiply to 90, add to 19. So we'll do the 9x and the 10x. Factor, so we get 3x plus 5, 2x plus 3. And then if you set those to equal 0, you get negative 5/3 and negative 3/2. So the same answers. Two different ways of approaching it. And when you check these, I believe they both work. So here's what we've got. If you have not finished the 5.4 Math Excel, that's your top priority. I went ahead and opened up a 5.5 Math Excel. We will have a work day tomorrow for that one. So it's not homework, but if you're done with the first, you might as well go ahead and start it while you have class time. Especially some of you I know might have something important going on tomorrow night, maybe don't want homework tomorrow night. So that gives you a chance to get ahead of it, but you will have